Welcome back. This video is going to be a quick review of projectiles, by no means a substitute for all my other videos. But anyway, a quick review of projectiles. Let's go through a little bit of each of the four types real quick. All right. So one type of projectile, the one I always like to start with, is the one where something is dropped from an airplane. It's rolled off the side of the cliff. Thelma and Louise shoot straight off the cliff in the question. Dun, 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 dun. So here I've got my cliff. And so what happens with this problem is you end up right here. Bam. You end up with this velocity coming straight off the top like this. And this object's going to make this nice little half of a parabola. Whee! And we're crashing. Alright, so this comes down. What makes this problem so nice? It's the fact that since you're starting at what would otherwise be the top of the projectile, we know what VOY is already in this problem. VOY has got to be 0. Every time we do this problem, we know that problem. We will have a Y, we will have an X, it might have a V. You're going to have on this end, you're going to have a VX, you're going to have a VY. If you're asked to just find velocity, do Pythagorean theorem and you can just find the velocity. This is your variables. You'll usually have your VOX. It may ask you to find your VOX. Just stick to your basic projectile equations. What's the only equation good for the x direction of a projectile? X equals VOXT. There. What are your equations for the y dimension? Vy equals VOY plus AT. Y equals VOYT plus 1/2 AT square. Vy square equals VOY square plus 2AY. Bam! And so this is pretty much everything we really need on the projectile equation. We want to always find VOX, VOY, first priority, VOX, VOY, which is why we love this problem. It's because it gives us this. This problem now could do one of many things. It could give us VOX. Let's say it does give us VOX. Let's say that VOX is, 20 meters per second. Now this problem could give us X or Y. It's got to give you, though, one more piece of information. Let's say that it gives us, in this case, let's say that it gives us Y. And let's go with X. Let's say that X in this case is 20. There we go, 20 meters per second, and it goes 20 meters. So that should make some easy math. So the question might ask, how high was the cliff? And this may not be much of a cliff at all in this question, but we'll find out. Well, look at what you've got, X and VOX. What can we now find? We can find time. So we know that X is equal to VOXT. So in this case, X is 20. Lo and behold, VOX is also a 20. So there we got 20 divided by 20. So we've got a 1 second time. Can we use that time now to find this height? You bet we can. Y equals VOYT plus 1/2 AT square. And lo and behold, VOY we said was 0. So we can scratch that out. Y equals VOYT. So it's just 1/2 negative 9.8 times 1 square, which would be negative 4.9 times 1 square. This problem only come off a negative 4.9 meter tall cliff. So our cliff was actually very short in this problem. Could we find VX? Well, yeah, it's the same. It never changes. V in your X never changes on the projectile. It's always 20, 20, 20, 20, 20. Which means down here, it's still 20. When you get down to here, it never changes. Could we find VY? Well, certainly. We could go, little Three Stooges reference. We could go straight to this VY. VY equals VOY plus AT. VOY 0 plus negative 9.8 times time, which was 1 second. So it's negative 9.8. So we've got negative 9.8 for that velocity. Could we find this resultant velocity? Oh yeah, it's like a hiker in the woods. If I want to find this resultant, all I'm going to do is take the 20 square plus 9.8 square. Yes, I know it's negative 9.8, but we're going to square it. Take the square root, and you've got this velocity now. If you wanted to find this angle it hits at, cool. Use tangent, just like in the vector video. Do your theta tangent -1. That made no sense. But anyway, come back in. Theta would be equal to tan -1 of the opposite, which this Vy is my opposite. It'd be 9.8. The y component's always your opposite in these vectors. And then your adjacent components is x over 20. Plug that in, and you've got all of that information. So look at how much you're able to try and do using this. I'm running long. 6 minutes into this video. All right, so what about this type of problem where something is shot up? No. Back to the ground we go. I call this my perfect parabola question. I love doing the little perfect parabolas. Excuse me. Again, what if it gave you, let's say that this one gave you 20 meters per second again for a VO, and it gave you an angle of 40 degrees. Your first assignment, should you choose to do this, and you should choose, it's worth it. Find VOX. How do you find VOX? 20 cosine of 40. How do you find VOY? VOY is equal to VO sine of 40. Go to bed tonight thinking VOX, VOY, except I forgot to write VO. I literally wrote VO, but it should have been 20 sine 40. And so for me, I can come in here now, 20 cosine 40, bam, close that. I got 15.3. Now can I find VOY? Oh yes, I can. 20 sine 40, close my parenthesis, 12.9 meters per second. If I can get VOX and VOY, I'm not worried about the problem. I know it's doable. It's when I don't have VOX or VOY that I get a little bit more nervous about the question. So there's my basic projectile. If this problem now asks me how high, I'm going to go straight for the third equation. Vy squared equals VOY squared plus 2AY. Straight to the third, because I know that the velocity right here is 0. This Vy being 0, it allows me to find maximum height. It also lets me find time to the top if I want to use the first equation. What if this problem didn't ask you how high? What if it asked you to find x? Well, the only equation good for the x direction on projectile is, for the 3,000th time, VOXT. Cool, we've got VOX. Crap, we don't have T. Sorry for saying crap in this video. But anyway, we don't have T. How can we find T? Well, if you've watched my videos, you've heard me say it over and over. What is my go-to equation? I'm talking the go-to for time. What is my go-to equation for time? Second equation, y equals, I almost messed it up, VOT. Wow, I just mauled that. Getting excited. Y equals VOYT plus 1/2 AT squared. What is my y for this? I went up and I came down. What is my vertical displacement? I started here, I finished here. Yeah, that's x, but in terms of y, it's like going up and back. My y is 0. If my y is 0, VOY, you've calculated, is 12.9. T, half of negative 9.8 is negative 4.9 T squared. Since this is 0, that T cancels that square. Now look at this. Negative 12.9 equals negative 4.9 T. Look at how convenient this math turned out for us. 12.9 divided by 4.9 equals derivative, what am I saying? I'm getting classes mixed up. 2.6 seconds. There's my time using my go-to second equation. Slip right over here to VOX. 15.3 times 2.6. 15.3 times 2.6 equals. And now I'm not going to do one of everything in this video. There's an x though for this one. So cool. We found x. So we found, well, we didn't find it, but we could find maximum height just by setting that Vy as 0. 12.9 squared minus 19.6y. Bam. That would give us this maximum height. How high? When I say how high, you say, I feel like I'm a member of some kind of a weird organization the way I keep doing repetitive things over and over. But then when you teach physics for 15 years, your whole life is deja vu, really. It's craziness. It's craziness. Now, I'm not going to work one of these questions where something is thrown off of a building. Same priorities, though. Find VOX, find VOY. VOX is VO cosine theta, VOY is VO sine theta. The big thing is this. If you are asked to find time, if it tells you that this thing is 100 meters tall, that it's getting thrown off of, make sure when you plug this in to the third equation, you make sure that you plug in negative for that 100 in that third equation. If you're trying to find that time, you plug in negative so you don't mess that problem up. All right. So I've got one more thing here. What about if we've got, well, I'll make a special video for that one problem. So I'm about to run out of time. I'm about to have a group of students in here. But I'm going to make one more problem, and that's going to be, how do you work out this famous problem where you've got a theta basketball player question? How do you do this problem? You've got a y, x, we'll say that theta is 40, x is 20, and y is 5. How do you find what that VO has got to be to clear the wall? So I will leave you with that, and I will come back with a projectile part 2 review video where we work this problem. There you go. Take a break. You try and figure it out. Are you done yet? Well, if you came up with y equals tangent theta x plus 1/2 at squared, you're doing very good. I guess we'll wait till the next video. Hey, thanks for being patient with an old dude. Later.